Welcome back to networknuts YouTube channel. I'm Alok Shrivastava. In this video, we are going to talk about a very interesting thing, that how actually when you hit on the service, the request goes to the pod, right? This is what we are going to learn. Normally, what we think something like this, that okay, it's very easy. I am the user. I hit on to the service IP, right? And the service IP refers me to the endpoints, right? This is the endpoints, the pod IPs. But how it all happens? Does service really exist? Means, is there a resource or a process which is running with the name, with this IP address, service IP? So all this we are going to learn. So normally, what happens? Let's understand what normally happens when you are hitting a service in a Kubernetes cluster, right? So if you ever try to ping to the cluster IP service or any service, it will fail. And there is actually no process running on the service IP. So even if you try to do a netstat and then the service IP address, you will not be getting any output. That means it's not a resource. Service doesn't exist. Service exists only in etcd. There is no process running on that. So how it all works? That sometimes bamboozled me. So what happens? Let's understand this. So let's suppose this is the scenario, right? Under normal condition, what happens? Suppose the black pod wanted to talk to the service, right? 172.17.0.17, which is then connected to two endpoints, two red pods, 10.0.2.1 and 10.0.2.3. So when this pod send the request, it goes something like this, right? From will be having the pod IP, and service, and to will be having the service IP, right? So what happens then? We normally think, okay, my request goes to the etcd, right? This is what we normally think, that this request goes to the etcd because service exists only in the etcd. etcd checks the service then refers the endpoints. This is what we think. This never happened. Your request never goes out of this box, node 1. Oh my god. Then what happens? See, now this is, so whenever you hit onto a service IP, like here I am hitting onto a service IP, the moment we know that the service doesn't exist, I will tell you this. So let's do one thing. Okay, let's understand this and then I will show you it. So services are not actually acting as a load balancer, which we normally think, because in order for the service to act as a load balancer, service should be a process on that IP, but we will see that there is no process with that name. So the moment the pod 10.0.0 like 1.1 tries to talk to the service, right? Before your request goes out of this node, it refers its IP table. Wow, IP tables, right? We had never seen IP tables during our Kubernetes training, but this actually happens. The moment you press enter, your request refers your IP tables, right? Now IP table knows that service doesn't exist. It's simply a virtual IP. Then what it does natting, right? Your IP table removes the service IP, referring the IP table, it puts any of the pod IPs. And now using the cluster network, 10.0.1.1 will be able to talk to 10.0.0.2. That means the moment this packet is trying to go outside the node, it is referring its IP table, right? This packet refers the IP tables. We will see it, right? And in IP tables, there will be a reference that if someone hits 172.17.0.17, in my case, that should be natted to any of the pod IPs. In my case, 10.0.2.1 and 10.0.2.2. So means actually when the packet moves out of your machine, this is already being removed. There is no trace of the service. no reference of service. So let's see how it works. Let's check this out. This seems to be interesting, right? So let's check it out. Now it is the Kube-Proxy, but the point is I never added any rule in the IP table. During, if you had done any like formal training like CKA, or you are aware of Kubernetes, you never added any rule in IP table. Then who does it for you? Who add those NAT rules in the IP tables? Kube-Proxy. Kube-Proxy collect those endpoints and automatically populate the IP tables. And we know that Kube-Proxy is a daemon set which runs on every machine automatically, right? Now let's check it out. So let's create a pod. So when I create a pod, right, this, now we need to understand this. There are two states which is being stored in the etcd. One is the control plane and the etcd state, which is storing which pod is running on which node, right? So if I take this example, the black one is running on node 1 10.0.0.1.1, red one is running here, red 2 is running here. So this entry is there in the etcd, that which pod runs here. So currently I hadn't created any service, so it will be blank and there will be nothing in the Kube-Proxy state. So let's first do this. So let's create a deployment, right? So let's create a deployment and see what happens. So I have this machine. So if I check it, kubectl get pods, I have nothing here. Oh, I'm on node 1. Sorry. I have to be here. So I give the command kubectl get pods. I have nothing here, right? Now I create a deployment. Kubectl create -f test depth, right? It created a deployment. So kubectl get deployment. It created a deployment, right? Kubectl get pods. It created 2 pods. One is running on node 1 and another is running on node 2. Perfect. That means when I had done this, this thing happened in the etcd, right? The control plane etcd, that which pod is running on which node. This got added. Now what? I need to create a service, right? The second thing, I will be creating a service for the red pods. Service IP. The IP will be different, right? Now, it's a virtual IP address and it will automatically capture the endpoints. So if I create a service, if I check it out, kubectl get service, let me see. Okay, I do a kubectl expose deployment. The name of the deployment is web app -- name of the service is, I say web app svc. So I created a cluster IP type of service, right? If I give the command kubectl get svc, I got it. And if I describe it, kubectl describe service web app svc, I see the endpoints. We know this. Now what we normally think, okay, when I hit onto this, the information about the etcd, sorry, the information about the service is stored in the etcd. So my request goes to the etcd first, right? This is normally what we think, that whenever I am hitting, my request is going to the etcd. From etcd, it refers the service get the endpoints, and then I will be able to talk to the machines. These are the pods which are running, right? No, it doesn't happen. So we created a service. The moment I created a service, this thing happened, right? A service is created which connects 2 pods. Now, a floating IP is automatically created, and the service also got the endpoints where the traffic should be directed. I know it. Now what? The moment the service is created, the Kube-Proxy, right? We created the service. So once the service is created, this got updated in my etcd, right? That we have a new service which has got these endpoints. Please understand this. This is before creating the service. Check the state, and once I create the service, this got added here. So here it is red service. In my case, it is web app service, and the IP is different, but the endpoints are there. Now the moment the service got added, right, Kube-Proxy will get a notification. Kube-Proxy keep on monitoring any changes in the control plane. Please understand this. Kube-Proxy daemon, right? Kube-Proxy keep on monitoring any changes in the control plane, right? It found that, oh, a new service is there with 2 endpoints, right? So Kube-Proxy notifies this change that this has happened. Now what Kube-Proxy does, right, this is a notification. It will add that entry in the Kube-Proxy state, that if something comes on 172.17.0.17, I should replace it with this, right? Now this rule, this is the rule, right? What Kube-Proxy does, it converts this state file, this state entry into IPtable rules, right? It converts this into a IPtable rule, and we know that the Kube-Proxy is running on every machine, right? Now what happens then? The moment a service is added, right, Kube-Proxy take this entry and creates a IPtable rule, and Kube-Proxy then modifies the operating system and add that rule. The green tick means that IPtable is modified on all the machines. Why on all the machines? Because Kube-Proxy is running as a daemon. It is running on all the machines. So every machine will have the IPtable modified for this natted corresponding entry. Let's try this. Let's try this. So if I show you this, let me do one thing. Let me remove everything and then see, right? So we will see the number of rules in the IPtables. So I'm going to remove this. kubectl delete service web app service, right? And I'm going to delete the deployment also. kubectl delete -f test app. Now let us go to the nodes and check the IPtable number of entries, right? So if I give the command IPtables, say -t nat -f list, and I do a word count, right, number of lines. So let's see how many number of lines of entries it has got. 141 lines, right? And I can also give it with IPtables -f list and do a word count. So 153 lines, right? And this is on node 1. Repeat the same command for the node 2. Let's check it out. I copy this. So this one has got how many number of lines? 141, same number of lines, right? And if I repeat it, this might be different, but normally it comes out to be same. 10, fine. So 141 rules are there in the nat table, right? Now let me run a deployment. Now see it, guys. And that is why we always say that you should be very good with Linux, right? Now let's create a deployment. kubectl create -f test dep. I created a deployment. Pods get created. Get pods -o wide, right? And I create a service also. kubectl expose deployment web app -f name of the service is web app svc, right? The moment I does this got picked by the Kube-Proxy, right? This got picked by the Kube-Proxy, and it is the Kube-Proxy. Please remember, it is the Kube-Proxy which add the rules in the operating system IPtable. It is the Kube-Proxy which does it. So Kube-Proxy is modifying your OS, referring his table, referring this table, that what rule I need to add, right? So let's check it out. So if I go back, so I created this. If I go back and repeat the same command, let's see, nat list word count. Earlier it were 141 rules. Check it out. Now we have got how many rules? Let's see, 158 new rules are added, right? Here also, if I repeat the same command, let's check it out. So 158. Now let's try to understand the rules. If we need to understand the rules. So when I hit on the service IP, see what we normally do. We hit on the service IP curl http // and we hit onto this, right? I'm getting the request from any of the pods. People normally think it is the service which is doing the load balancing stuff. No, service is not doing the load balancing stuff. Service is not a process. Service doesn't exist, right? The load balancing setup is done by Kube-Proxy, right? So what it does, let me show you. If I give the command here, Now check out the IP of the pods 141 and 1091. Now see it carefully. If I repeat this command nat list, right? If I repeat this command nat list, and I can check the kube services also, -L, chains are there, lot of chains are created. If I do a -T -F list, see here, a lot of chains are created. So we will have a chain for our service, kube service. See here, these rules are automatically added by the Kube-Proxy. If I see the service one, kube service, right, and I can check this, see, you can see this web service, my rule, right? Or I can do one thing. If I can simply take the chain, that particular chain, and do a -list of kube services, kube services, right? And -n number, and I can put it in column. Right, let's try this. See here. So this is my service, web app SVC. The destination is 10.105.90.105. This is the IP address of the service, right? So this node 1 has got an entry, right? And the target is this. This is WMQ. This is the chain name, and this refers to my service. The same entry will be there in node 2 also. If I repeat the same command. So these rules are populated. See, same web server SVC, right? Now, but isn't it, I will be hitting onto this. So this will be referring to my pod IPs somewhere. So if I just give the command nat list and read carefully, what are my pod IPs? My pod IPs are 141 and 91. Okay, here I am. It takes time. Yeah, now see it carefully. 141 and 91. Isn't it? This is my pod IPs, and this is the Cure ID ending with WMQ. See here, my service reference was ending with WMQ, cube chain. This is the chain which is hitting onto my service, right, ending with WMQ. So when someone hits onto the WMQ, it is taking it to this IP. But where then this IP will take him? When someone hits this, where the IP table should take him? That you can check it by referring this WMQ. So if I move down in my chain WMQ, here it is, yeah, here it is, WMQ. Now check it out, guys. It's a masquerading happening, right? So when someone hits 10.0.190.105, which is the service IP, right, it is sending it to any of these two pods. Check it out. 192.168.10.91, which is the first pod IP, right? And 192.168.341, which is the second pod IP. See? So that means this got added in the, so the means your request on the service IP, please understand this, your request on the service IP will never leave the machine, right? The moment you hit onto this, it will refer its IP table, and IP table says whenever someone hits onto this, you should masquerade that IP, remove the service IP and add any of this IP. Means this is what is happening. This is what is happening. So when you hit onto the service IP got cut, it replaced by the pod IP referring the IP table which is in the machine. This is the NAT table. So this happens in pre-routing, right? This happens. So if I have got more pods there, I will have more entries here. I will have more entries there. The same thing will be happening here also. If I repeat it, NAT list, check it out, WMQ, right? And when I remove this, it will be removed. See, WMQ. on node 1 also the same thing is happening. 10.91 and 3.141 my IPs, right? And I have a reference WMQ, web server SVC. So these entries got populated, are added automatically by the Kube-Proxy. This is how actually internally the services are talking to it. So if I go to the machine, my machine here, and I give the command manager IPtables -tnat -list. Let's check it out here also, right? Let's see here also I've got a WMQ entry. WMQ. So when you hit on 10.105.90.105, you will be before the packet leaves the machine, it get automatically the target IP got replaced by the pod IP, and now using the cluster network, your Calico and whatever, the communication happens, because that is what the Calico guarantees, right? And if I remove my service, if I remove my pods, you won't see these entries. It will be automatically removed. So this you need to understand, that who populates. Your IPtables got referred automatically, right? And it is the Kube-Proxy which keeps on modifying the IPtable rules by continually monitoring the control plane. So the moment you add any pod, you add it, add, delete anything in the control plane at CD, Kube-Proxy got alert that, oh, something changed. It then changes his database, the service IP, and then add this rule. The same rule got added on every machine IPtable, the green ticks. I hope now you understand how actually communication happen, right? So this is very, very important for you to understand that how actually the communication happens, and your request, the service IP request, never leaves the machine, because that doesn't exist. If I try to show you this, the service is not a process. It doesn't exist. So if I try to do a netstat -tulnp and pipe grep of 10.105.190.105, if it is a process, I should be able to see it. It doesn't exist. This exists only in etcd. This exists only in etcd, right? So this is what I want you to understand. Now let's remove it. So if I remove it, kubectl delete service web app SVC, so the entries will be populated automatically, right? And I delete the deployment, kubectl delete -f test dev. Let's check it out. So if I go to any of the nodes, earlier we had an entry of WMQ, which is having my web service SVC is pointing to these two actual pods, right? Actual pod IPs. NATing is happening. If I repeat the same thing, that is gone. That is gone. I have no reference of that service. I can check it in the service chain. There is no default. There is no reference of web server SVC. When there is no reference of web server SVC, there are no pods, nothing. So that got populated. That is why the number of entries in the IP table automatically add when we add a pod, when we add a service. And you should thanks to Kube-Proxy for doing all this for you in the backend. I hope you have understood it. Do share your feedback. If you like it, share it, subscribe it. It's up to you. And keep on watching, keep on learning new things. I'll be back soon. Till then, take care. Godspeed. Jai Hind.